All right, guys, here we go. Next part of integrals. All right, you've all been doing a great job with submitting stuff and you making sure things are on time. You're doing an awesome job. So we're gonna keep this thing rolling here and rolling forward. All right, with indefinite integrals. Now, remember last time we talked about definite and indefinite integrals. All right, those are the two that we're gonna look at. For now, we're just focusing on indefinite integrals. All right, no boundaries. So just kind of refreshing from last time, right? First, you always want to make your life easy, all right? So for us, simplify it, meaning distribute just like we've always been doing, write it as an exponent. We don't want radicals, all right? And we don't want fractions. So if we can write it as an exponent, we got to write it as an exponent. It makes our life easier, right? Second thing, and this is what we're going to move into a little bit here today with trig functions, all right? You want to make it look like a trig function that you can easily locate on your cheat sheet, all right? So if you flip your cheat sheet over to the back, right, the top part of it was all derivative stuff. On the bottom part, all right, that's all the integral stuff. So we want it to look like what we got on that sheet, and I'm going to be giving you some additional stuff here today as well. So we talked last class about the power rule for integrals, right? Where we add one to the exponent, put it over the new. Don't forget Carlos, all right? The exponent can't be a negative one because if you add one, you get 0. No zeros in the denominator, all right? Calc God's got something else for us later down the road. So just don't forget Carlos. All right. And for us, we're going to take another step forward here today. All right. If we integrate a constant, all right. If we integrate a constant, we're just tagging it with an x. All right. Because there is no variable there to add an exponent to or take one away. And add 1 to the exponent of and put it over the new. So if it's just a constant, the x is going to show up. All right, so here we go. For example, if we had something where we were just integrating a 2. All right, 2 is a constant. So when we integrate it, we just put an x with it. So the integral of 2 becomes 2x. All right, don't forget Carlos, right? Remember, integrals are the opposite of a derivative. So if we derived this, 2x would become 2. Constant would go away. All right? So if you're ever integrating a constant, you're just tagging it with an x. Again, just refreshing the memory here, right? If we're going to integrate what we got here, we're focusing on the x to the 5th, right? So when we integrate, add 1, put it over to the new. It becomes negative 24, right? And then that x to the 6th over 6, because we integrated it, not forgetting Carlos. And then these can reduce. We can reduce that negative 24 and that 6 and make it into the negative 4x to the 6th. All right? Here, it's already written as an exponent for us. So we're good. However, keep in mind, it may also be written in this form, and we have to write it like this. All right? So keep that in mind. When we go to integrate, focusing in on the x. Careful with your signs. Adding 1, putting it over the new. We can reduce those out. All right? We don't forget Carlos. Okay, and then again, don't forget, put it back with a positive exponent. So it becomes negative 1 over x to the 4th plus c. Here we go. Stepping it up a little bit. We got a radical. We don't want that. We're going to rewrite it as an exponent. So it really becomes negative 5x to the 2/3 over 3. You can leave it like this and integrate that x. Keep in mind, if it's written either of these ways, it's the same thing, and I'm not going to be picky with that. Now when we go to integrate, integrating that x to the 2/3. it becomes x to the 5/3 over 5/3. You gotta be a beast with your fractions here, right? We need a common denominator of 3, so it's really like we're just adding that to the top number and keeping the bottom. Dividing by a fraction is the same thing as multiplying by the reciprocal. In this case, when we multiply by 3/5, the 5/3 and the 3/5 reduce. They cancel out. Okay? We're left with what we got here. And we got to put it back as a radical. We don't want to leave it as an exponent. Final answer is the negative cubed root of x to the 5th plus c. Okay? Here we go. Again, this is all just getting the brain moving, right? How can we reduce this out? Negative 14 over 7? Whoa. Hold the phone. There we go. Negative 14 over 7. We could reduce it to the negative 2, right? So really it just becomes negative 2x to the 5th. Integrate it. Focusing in on the x. It becomes x to the 6th over 6. We can reduce that out. All right. Remember that the 6 is in the denominator. So when you do go to reduce it, you got to keep the reducing in the denominator, right? It really reduces to 1 negative 1/3. And again, if you wrote this x up top, it's the same thing, all right? Hope everybody's good so far. All right, here we go. Let's roll. So trig functions, all right? You can add these to your cheat sheet, all right? So you will see that your cheat sheet does have these on there, okay? And I had provided you an additional one with these on there, but it doesn't have the over a at the bottom, all right? And that's important, all right? So that a is the constant with the x. So for example, if it's cosine of 5x, all right, or I'm sorry, sine of 5x, when we integrate it, it's negative cosine of 5x over the 5. All right, so again, keep in mind what it becomes. Sine becomes negative cosine. Cosine becomes sine. All right, and so on. So again, you will have this. It's up there on Genesis. All right, and this is, if you're feeling crazy and want to add it to your cheat sheet, rock and roll. All right, let's take a look at this now. Here we go. Let's do some integrals. So cosine 4x. All right, here we go. Cosine integrates to sine. So cosine 4x becomes sine of 4x. Because the 4 is with the x, it goes in the denominator as well. All right, and then don't forget Carlos. Sorry, my computer glitched. All right. Here we go. Negative 3. Cosecant of x, cotangent of x. This is a constant in the front, so it does not affect how we integrate the trig functions, just like always. From the cheat sheet, cosecant of x, cotangent of x integrates to negative cosecant of x. All right? They both have the imaginary 1 in front, right? Hence why we're putting it over the 1. Remember that constant in front. You don't have to in this case because it doesn't affect our answer. When we multiply that, because negative 3 is the constant, right? When we go to simplify again, it just becomes positive cosecant of x. All right, here we go. Focusing in on this. Constant doesn't affect us. Sine of 5x integrates to negative cosine 5x over 5. Negative 2 is the constant in the front, all right? We can write this simpler. Just put that negative 2 to the top with that negative cosine, and we can write it as negative 2 cosine of 5x over 5. All right, hope everybody's rolling with me here on this. All right, now, all of these were hunky-dory because they were all right from the cheat sheet. Sometimes what's going to happen is something like this. All right. This is not on the cheat sheet. So we got to make it look like something we know. We can rewrite secant of x, all right, as 1 over cosine, because that's what secant is, 1 over cosine. Trig identities, all right? If we keep simplifying, dividing by a fraction is the same thing as multiplying by the reciprocal. So in reality, this is this. We know how to integrate that. So you may have to do some rewriting to make it look like something you know. All right? Now we're good. Well, the 2 doesn't affect us. Cosine of x integrates to sine of x. It's over 1 because of that imaginary 1 in front. It doesn't affect us. Simplest form. All right? As always, guys, keep reaching out to me if you got questions. All right? I'll be helping you. Miss you guys. You've been doing an awesome job with everything. Like I sent out in our email, all right, all assignments are going to be due by the start of our next class. All right, so when our next class is, whatever time we would normally be sitting down at the desks to check the homework, right, that's when it's going to be due by. So the start of our next class. All right, as always, reach out, guys. I miss you guys. Hope everybody's well and healthy, and I'm looking forward to getting back. All right, see you guys.